Okay, so let's keep working away at this thing. I added in get current URL because that one was sort of obvious. What should we do about when people want to see what's going on with forward and back? What's going to happen in the browser here? You've got something there, and we'll just assume that there's stuff magically here. Somebody comes along and presses the back button. So there's the thing that they're going to do. They're going to hit the back button. What do? You take...
You have to take current out first and put it into forward.
Current goes into forward, and you take the thing off of the backward and put it up there. Okay. So you can sort of start playing the game of writing it here. The other thing that you can do is you can go and you can say, well, let's just do a test case that does that, since that's what I'm going to have to do anyway. So a test case would be the user hits the back button. Okay, and I've got this history class pre-made for us, so there's a web history thing, and I pre-made a bunch of sort of web address stuff in there that should be A, B, C, and D for URLs, whatever they happen to be. Okay, and if you wanted to do, well, I guess we should do the setup. Well, let's just suppose that there's something there, and we'll worry about the setup later. So somebody hits the back button. I guess we do have to do setup, don't we? Otherwise, it'll be difficult to figure out. Okay, that's fine. We'll put, instead of the back button, we'll do the simple thing. Somebody types one thing or hits enter. We'll call it hits enter is probably better. So suppose the user types something and hits enter. So you're going to talk to the history thing, and you're going to go history dot whatever you want to call it, set current. Hits enter is actually probably better, isn't it? So they hit enter and they give a URL, which is the A address. Probably not the best naming for that. Okay. If they hit enter and do A, what would you expect to see? So current, let me just steal that one. If we get the current URL, it should be exactly A address. Anything else?
Forward and backward should be fine.
History dot get forward what? Size would be the easiest one. So if it had a size, we should say the size should be equal to 0. What should the back size be equal to at this point?
Also, the only thing that was in it previously was just a blank URL.
So there was nothing in there, so if we're lucky, the backward size should be 0. Okay? Notice that thinking it this way gives you an idea of what you should write here. So we need a hits enter, public void hits enter, and you supply a web address, whatever it happens to be. There's public int get forward size. Oop, that's putting this in the wrong place, aren't I? And there's public int get backward size. Okay, so get forward size just returns, this is easy, forward dot size. And get backward size returns backward dot size. And when they hit, I just called it back just to be different. Okay. And when they hit enter,
It should set current.
current URL equals the address. What should happen to the backward stack?
Nothing. Won't. Yeah.
So-
It's current.
So it should be backward dot push whatever's in current URL. Current becomes that. What about the backward stack? Or sorry, the forward stack. What happens in a web browser if you start typing stuff? What happens to the stuff that's in the forward stack?
It gets wiped out.
It gets wiped out. So that's forward dot, might as well use it, clear, since it's there. Okay, and I'm out of sync with something, thanks to my friend Git still. Okay. So notice that we got an API going fairly quickly. We know what happens when it hits the enter key. What happens when they hit the back button? We'll just do one more.
Current goes into forward, and then pop back and put it into current.
So forward dot push current URL. Current becomes
Back pop.
pop the one off the back stack. So the back has changed, current has changed, and forward has changed. So we got them all. Okay, something like that. Okay, and you could write the unit test for it. So I don't want to take this one any further other than to show you that look what we've done, right? I mean, we've taken the idea of that the web browser had for manipulating things, and we've made a class that's in charge of basically shuffling things between three variables, forward, back, etc., to keep them in sync to what they're supposed to be. The unit tests and getting the rest of the code in there are sort of trivial, other than having to worry about what you do for the first ones, sort of thing. So I don't want to spend too much time on it, other than to show you there's an easy use of stacks that you're probably already used to. All right. So now let's go on to a more fun use of stacks, because I want to get to beer. So here's the problem. It's Friday night. Nobody has any money, but you're in high school, so you get somebody to buy you a few cases of beer, and you're going to go into the forest someplace and drink while you're underage. I assume nobody here has ever done that before. Okay? But so what you've done is you found somebody whose parents happen to have an acreage, and the idea is, well, we'll just go out someplace into the bush and we'll drink some beer where nobody can hear us or see us. Okay? And just to make things fun, what we do is we decide that we're going to play a little game of hide and seek. We're going to go put the beer in the forest someplace in the middle of the night, and we're going to make people go look for it in the dark, just for the pure fun of it. But because we're lazy creatures, we decide that we're just going to have one person do it. Okay? And so what we're going to do is we're going to go earlier in the day, and we're going to hide some beer in the forest, and then we're going to all gather at the house, and we're going to wait for a while until it gets dark, and then we're going to appoint one person to go running through the brush in the dark trying to find the beer. Okay? Sounds like fun. Eventually that person is going to discover the beer, and then their job is going to be to tell the rest of the people where it is, hopefully, so that everybody else can join them and go drinking. Okay? So let's see if we can set this thing up. I'm going to draw a diagram here. Here's the house. And if you think about a forest has got sort of a bunch of paths leading from the house, the sort of the deer trails where you can sort of walk through. And then those things result in clearings. Okay? And then from this clearing, you might be able to get to a bunch more things, and you end up with something that looks sort of like that as a diagram. Okay? And so just for fun, what we're going to do is we're going to number all of the clearings. Okay? We're going to draw ourselves a little map. Okay? And then the person who goes out with the beer is going to go and place the beer someplace in one of the clearings. Okay? And what we're going to do is when it's time to go drink the beer and it's gotten dark, we're going to give somebody a map like this, only we're not going to tell them where the beer is, and we're going to say, I want you to go running through the forest and see if you can find the beer. And as you're running through the forest, I want you to be on your cell phone, and every time you go someplace on this map, I want you to tell me where you're going, just so that I can be assured that you're doing the right thing and not sitting someplace drinking beer, right? Okay? So what we'll do is we'll have you start here, and you're going to say something like, I'm at clearing 0, and I'm headed towards clearing 1. Okay? Oh, clearing 1, let me check, there's no beer there. I'm going to go and check clearing 4 and see if there's beer there. Okay? Oh, no beer there. I'm going to go back to clearing 1, et cetera, et cetera. Okay? So this dialogue that you're keeping on the phone is just this sequence of, I'm at clearing such and such, beer or no beer. If there's no beer, here's where I'm going to go next, or here's where I'm going to go back to go someplace else. Now, we want the person who's checking for the beer to be sort of thorough and to have gone through all of the clearings when all is said and done to make sure that they've somehow located the beer. Okay? So there's the basic problem. To make things more difficult for you, I want to write a Java solution to solve the problem of the person who's hunting for the beer. And I want the Java solution to work for any kind of forest, no matter how big it is. Okay? All the way up to the Amazon, with lots of clearings and lots of places to put beer. Okay? And people should be able to, whatever code we write, be able to move the beer even within the forest. And what we should get when our program runs is it should say, oh, okay, go through the dialogue of saying, I've gone and I've checked this, I've checked that, I've gone back here, I've gone back there. And the final thing that the program should do is it should tell us how to get to the beer. Okay? So it should, as a final thing, say, you better hurry up. If you want to get some beer, you have to go through 0, 1, 6, 11 to get to the beer. Okay? That's the task. Now, you know how to write if-then-else statements. But the problem with this is that if you write if-then-else statements that are specific to just this particular forest, you'll have to rewrite the code for another type of forest. And I want code that works for any type of forest. How are you going to write the code?
It's going to have to be not based on the values exactly. It has to be completely workable to whatever the forest is.
It has to be general, right?
Yeah. It can't be specific at all.
Okay. So we have to write some.
A lot of conditions.
Isn't every map different? Every map is going to be different. So I could totally rearrange the forest to have different points in it.
We have a clearing class that has an array of clearings in it.
Well, you're getting a little bit ahead. The first question is sort of like, how to be, if we were just doing this by hand, how are we going to be thorough and decide whether or not we've gone through every single clearing? Okay, we've got to have some technique for going through and discovering things.
When you enter a clearing, always use the either leftmost or rightmost.
The other problem is the leftmost and rightmost is going to be so weird because you can have as many clearings as you want from one clearing. None or lots and lots and lots. Okay? It seems like it's going to be a difficult problem, but let me help you with a solution. If I do this, make a to-do list, I'm going to make a to-do list, and I'm going to start and I'm going to say, there's where you should start doing your work. Okay? And the rule becomes, if you're sitting there with nothing to do, go check the to-do list. See whether or not there's beer at that clearing. Okay? So in this case, we take a look and we go, what have I got to do? Oh, I need to go check clearing 0. Any beer at clearing 0? No, I can take it off the to-do list. What have I got to do now?
1, 2, and 3.
From 0, I can get to 1, 2, and 3. So here's what I'm going to put on my to-do list. Just all of the places that I could get to from clearing 0. Okay? Got nothing to do. What should I do? Oh, well, let's go check a clearing. Which ones should I check? Might as well take any old one. Look, 3's sitting there. Let's go check clearing 3. Any beer at clearing 3?
Nope.
Nope. Where can I get to from clearing 3?
3, 8, 9.
Not sure what that one is. I think that's a 9. So from clearing 3, I can get to clearings 8 and 9. Okay. Nothing to do. Sitting around, take a look. Oh, I guess I could check clearing 9. Check clearing 9. Any beer at clearing 9? No. Take it off the to-do list. What should I do now? Oh, I guess I should check clearing 8. Any beer at clearing 8? No. Take it off the to-do list. Done that one. What should I check now? Oh, clearing 2. Oh, well, I was at 8, so I'll go make the trip back to clearing number 2, and we'll check that one. Any beer at clearing 2? No, but I can get to 7. What's that thing there? It's a stack. Okay? So remember I said a stack was good for problems that had the sense of going back to. I've got some stuff that I need to get back to, or this idea of I've got too many things to do, so I need to just do one of them and then go back to doing all of the rest. All right? So that's the clue. Whenever you get that sort of a problem where you've got that sense of I've got stuff to go back to, which is the same thing we had with the URL class, right? or I've got stuff that's undone, then a stack is going to be the helpful tool for doing it. And it makes the problem really, really easy. Okay.
How do you keep track of finding beer?
Well,
Where to go?
the issue was, well, how do you keep track of eventually at the end, somebody comes along and says, I want the complete path. And the complete path wasn't in here. And the other thing you'll notice that wasn't in here was the sense of going back to. Okay, so there was no way when I was at clearing 8, I could say, okay, the next one to do is 2, but what I'd really like it to say, the program to say, is I'm going from 8 to 3 to 0 to 2 to describe the path that's actually being taken through the forest. Okay, so let's try this one more time with a little more detail. If I put clearing 0 up here and start the process all over again, when I checked clearing 0 for beer and said there's no beer, the problem is that I was wiping it out. Okay? Instead of wiping it out, what I'm going to do is I'm going to just leave a little breadcrumb there to say I've already checked that one. And then I'm going to go and I'm going to put the other ones on top of that. Okay? And now, when I go to check clearing 3, first thing I'm going to do is I'm going to mark it with the breadcrumb to say I've checked this. And then I'm going to go and say, oh, okay, no beer there. I can get to 8 and 9. Okay? If you want to check 9, we'll mark it, and then we'll check it. Anything interesting about the marked ones, if I read them off? It's the order that you get back to 0. There's the 9, the 3, and the 0. Okay? So the marked ones are our path that we're currently on, and they also describe, if I'm done checking 9, and I wipe it off, and I check 8, okay, and there's no beer at 8, and I say, oh, I want to go back to something, what's the thing I'm going to go back to?
The next marked one.
Well, the breadcrumbs are here. I'm at 9. I'm at 8. I've checked all of those. Which one am I going to do next?
2.
The first non-checked one on the list. Okay? So if ever you want to find going back to, you just go down through the thing this way and say, okay, the first unchecked one, even if there's spaces in between, happens to be the 2. The 2 is where I'm going back to. Okay? What happens if you encounter a checked one when you go to check something?
You go back one more because each one is unchecked.
So already checked it, nothing to do. Oh, already checked this one, nothing to do there. What's the next thing I have to do? 2. So each one that you take off there, it tells you the going back to, and it also eventually tells you where you actually want to go. Okay? So the trick is to not delete the information off the stack until you're done with it. Just provide some sort of marker to say, to indicate where you're going back to. Okay? That'll solve the problem. Okay? So it's relatively simple to solve. Now let's talk about how we're going to do this in Java. Let me start out by drawing a little table for you here. There's all the possible clearings. From clearing 0, I can get to 1, 2, and 3. From clearing 1, I can get to 4, 5, 6. From clearing 2, 7, clearing 3,
9.
8 and 9, clearing 4,
Nowhere.
nowhere 5,
10.
goes to 10, 6,
11,
7,
nowhere,
8,
nowhere,
9,
nowhere,
10,
nowhere.
11. 11 just happens to have the beer. Okay. So this thing is actually a unique identifier and a list of all of the other clearing numbers that I can get to from the current clearing number. Okay? So if we can make a table that contains that, then the problem becomes a fairly simple one of saying, oh, I'm at clearing 0, let me go through and check all these or put these things onto my to-do list. Okay, so let's start writing the Java for that. I've got this forest project, so we need to start making classes. What's the smallest thing?
Clarity.
So it's a noun, so we'll just choose that. What type of information is being kept for clearing?
Whether or not it has beer.
Oh, funny how you started with that, but sure.
That seems to be the focus.
If we do a clearing, are most clearings going to have beer? So what we'll do is we'll say has beer is false always to start with, and we'll add a public void set has beer So we'll always initialize them to false, and we'll give ourselves the opportunity to set one of them at some time to true. What other pieces of information? It's got some sort of identifier, and that identifier should come in there and be set. It has the stuff that it's connected to. What's the connection is what type of thing? There's more than one clearing. Well, so there's a couple of ways you can do this. You can say it's an array of clearings. You could make it a list of clearings if you want. I'm easygoing. The good thing about these is that they're going to be fixed size, so it's not going to really matter whether we use arrays or lists. So we'll go with clearing array, just for the pure fun of it. Okay, so a clearing comes in, and it's got an ID number, and it's also got a clearing array of I guess we'll call it in connection. And because it's not going to change, we'll just do that. We'll leave that for a second. That's probably enough. I guess we'll write get identifier. And that's probably good enough. We'll write, I guess, get has beer. And I'll leave the other one until we figure out what to do with it, how we want to actually use it. Okay, so we'll leave connections here for a moment. Okay, let's try writing a main program. And let's see whether or not we can make a single clearing. So if I wanted to make a single clearing, it would be clearing a clearing. I'm going to cheat here and write it all up top. It would be a new clearing. It would be 0.
And an empty array.
And where can you get to from 0? 1, 2, and 3, which are what type of things? Okay. That clearing thing is going to get in the way a little bit. What do we really need to know? Not necessarily clearings, but just their
Branches.
identifiers. So that could actually be just an integer array of their identifiers rather than the actual clearing. Let's just see if that makes the main program easier. So here what I would get is clearing 0, and I would get an integer array of clearings 1, 2, and 3. See if I've done that right. Equals maybe. Oh, sorry. There we go. The syntax is a little weird. Okay, so this is clearing 0, and I can get to the ID numbers 1, 2, and 3. Okay, so we'll call this one, more specifically, clearing 0, and let's just do a couple more here. If I wanted to do clearing 1, it would be a new clearing with ID number 1, and going to 4, 5, and 6. And let's just do one more, just that we start to get a little pattern here. If we were to do yet one more, it would be clearing 2 with a clearing ID of 2, and we can get to just 7. Okay, and this thing will make our arrays of only that size. So this one will be an array of size 3, 3, and the next one will be 1. So that's just a static allocation of the arrays. Okay, well, what I'm really doing here is making an array. You can see from the numbers that those are just values that are all clearing objects that are in an array. Okay, so let me just say this. I'm really making a clearing array of all clearings pardon me while I get the syntax right eventually. And it looks something like that, except now I'm just going to wipe out the zeros or the actual names. And I might need an equal sign there. I can never remember. There we go. And we'll change that to a comma. And we'll just tab that in. Okay, so it's the same thing. All clearing sub 0 refers to that clearing object, and that clearing object happens to have that lovely ID number of 0. So if somebody says, go find me clearing number 1, that serves as a subscript into this same array to pick up that clearing number 1 object. Okay, so we're using those integer numbers as indexes into this array again to find things. Okay, should we fill out the rest of our table here? So this is going to be 3, 4, 5, 6, 7, 8, 9, 10, and 11, going to 8 and 9, and then 4 goes to, so nowhere is just nothing, and that'll still give a size of 0 for the array. 5
10.
goes to 10, 6, 11, 7,
Nowhere.
8,
No.
all the rest are nowhere.
Yeah.
Okay, so there's the Java that represents that same table. Okay. So to give you an idea, suppose that we wanted to put the beer into clearing number 11. That would be all clearings sub 11 dot set has beer to true. And this is probably going to have to say static on the front of it just to keep things happy. There we go. Okay. So that sets the beer in the forest. What's the next thing you do after you get the beer in the forest?
Still looking for it.
What do we have in our diagram to start looking for it?
To-do list.
A to-do list, which is a stack. So what we'll do is we'll make a stack of clearings or to-do list is a new stack. Oops. Of only clearings, constructor. Make sure you do the import statement to get stack. And what's the clearing I want to start with?
Add 0. Clearing to the
To do dot push all clearings sub 0. Okay, does that all make sense so far? Okay. Notice one of the sneaky tricks that people don't use enough in programming is to use a table of values. because the table of values like this allows you to now change that table to be any kind of forest you want, put the beer anywhere, start at any position, and as long as those connections are formed and the table corresponds to the diagram, the code that we're going to write will work for any forest. Any forest, any size, beer somewhere. Okay? And rather than try to figure out and play with the algorithm today, that's a good place to stop. If you want to think about what you're going to have to do and do the algorithm ahead of time, go ahead. But tomorrow we'll start it with the simple thing. We'll just make the thing that says whether or not we can go through all of them first, like we did, and then we'll go back and we'll retrofit it to take care of whether or not it will actually tell you the going backwards part and mark the stuff afterwards. Okay, so we'll do it in 2 stages. See you tomorrow.